topic is capacitors in parallel. Here you can take 3 capacitors. The 3 capacitors are connected in parallel. C1, C2 and C3. These 3 capacitors are connected to a potential V. So this is the positive terminal. Here it is the negative terminal. So this terminal is positive. Here it is negative. Positive, negative, positive, negative. In parallel combination, the potential always remains the same. Only the charge is varying. So that the charge Q enter at this point, it can be split up into 3 different cases. One is Q1 through the capacitor C1, Q2 is the charge through the capacitor C2 and Q3 is the charge to the capacitor C3. So you know this equation V is equal to Q by C. From this equation we can write Q is equal to C into V. Then we can just write Q1 is equal to C1 into V and Q2 is equal to C2 into V and Q3 is equal to C3 into V. Therefore, the total charge Q is equal to Q1 plus Q2 plus Q3. You can write C1 into V is equal to, here you can take CV and here we can write C1 into V plus C2 into V plus C3 into V. CV is equal to V into C1 plus C2 plus C3. Here V and V cancel. We get the capacitance C is equal to C1 plus C2 plus C3. So this is the effective capacitance. So if we connect the capacitors in parallel, the effective capacitance increases.
If you found this video helpful, please like, share and subscribe to the channel. See you next class.